Okay, so this these tests are, you call that as a quarterly exams or?
These are unit tests.
Okay, okay, okay. So how was the maths? Did you perform okay?
Yes, uncle. Maths is actually yet to happen. It's going to happen on Saturday, coming Saturday.
Oh, okay, okay. Because I was thinking you said the maths that week Saturday, so it's only next week Saturday.
Oh, those were quarterly. Yes, yes, yes. Those were quarterly. That got over. Yes.
Yeah. So you did okay with the quarterly exam.
Yes, yes, yes.
Okay. Okay. So still let us look into the trigonometry because you need
Okay.
to develop some confidence over like any other um, problem. Trigonometry is also like you could do things very straightforwardly if you have a good understanding about that. Okay.
Okay.
So you have the basics of the trigonometry. I think you are okay with that. Let us start with a problem and then try to understand what are all the things we could do with that
Okay.
for solving that with our existing knowledge about the trigonometry. And then we will proceed further with what new things that can be done with trigonometric relationship and the functions, everything. Okay.
Okay.
Okay, let me send a snapshot in WhatsApp for
Okay.
the small problem with a triangle. So can you
Yes.
see the problem?
Yes, yes.
Okay. So you see, I mean, when we learn, let me share the whiteboard in our meeting. So as much understanding we could have about what is available and given to us, and what are all the other things that could be done with that, then obviously, I mean, the question and the problem, whatever they are asking, will be one among the things what we could do with the given information. Okay.
Yes.
So, I mean, even before going to angles or something, we learned when you have a right angle triangle, like if this is a right angle triangle, then two sides, the lower, I mean, we should have a D here. So there will be one longest length compared to the all the three side, and that is called the hypotenuse, right?
Yes.
Hypotenuse, and that will be always opposite to the 90-degree. That side will be the
Yes.
longest one. Okay. And obviously we know the sum of the three angles is 180. So if you consider this angle is a theta, then this angle will be
Uh, yeah, 90 minus 2.
90 minus theta. And you know, all these things should be in our immediately when we see a right angle triangle or a triangle, all the properties should pop up very quickly. And also even why the sum of the three angles in a triangle should be 180, everything you should know how to prove that and how that can be very much useful to solve problem, or when we are going to apply that kind of information or the knowledge, we should be always keep it handy. Okay. Because
Yes.
we learn a lot of mathematics and even physics concepts, chemistry, lot of things, but in reality when we eventually start using them, not in terms of exams, I'm talking about in reality, if you go for a job or
Hmm.
profession in the future, uh, the problems or the what we need to do as a work won't come as a exam problem like, okay, can you find the length of the other side? Do you get that?
Yes.
So it is our job or the responsibility to understand the situation, and probably we could use this kind of mathematical modeling and then the mathematical tool and what we could do further and everything. It is our responsibility. So nobody is going to give us straight away a problem and ask us to solve for this. Do you get that?
Hmm. Yeah.
So eventually what we are learning in the young age is all of them are knowledge and understanding. So in the future we will be solving problem, even we need to define the problem. It will be our job to find what is the problem, right?
Yes.
Okay, so for that only we are keeping our understanding as clear as possible. So apart from all this information, another thing what we know about this particular right angle triangle, even before the angles and everything with the sides ABC, what we can tell about the ABC? Is there any relationship connecting the ABC?
Yeah, A plus B will always be, it will always be greater than the length of C.
Yeah, I mean it's a particular case here, but in any triangle, the sum of any two sides must be greater than the
They are
length
always
of.
greater than the third side.
That is okay, but that is inequality. Do you get that?
Yes.
So inequality is useful for understanding and use it for some cases to check whether these three lengths can form a triangle or something like that. But in a special case of right angle triangle, when you know the three sides are ABC and C is the hypotenuse, then even we have a equality between them. What is that relationship?
Oh yes. So the square of the sum of the uh, other two sides of the triangle will be equal to the square of the hypotenuse.
Yeah, in this case it is actually C squared should be equal to A squared plus
A
B
square plus
squared.
B square. Yes.
So this we call it as the Pythagoras, because Pythagoras is the mathematician, Greek mathematician who invented this, and it is quite useful for us, right?
Yes.
And apart from that, in a right angle triangle, we have defined two basic trigonometric functions. That is, sine of theta is actually whatever the sine trigonometric function acting on the angle theta. Then we just defined that as in the right angle triangle. It is easy to find the sine or cosine trigonometric function in right angle triangle, but
Yeah.
we will learn later is not only that the angle has to be coming from a right angle triangle. Do you get that?
Yes.
Angle could be anything, so we need to know how
Yes.
to find the sine of the mathematical function sine acting on the angle. So in this case it is actually opposite side of the angle theta, right, divided by the hypotenuse.
Yes.
Okay, well and good. According to the given information, mathematically the opposite side of the theta is going to be
B.
our B over C, right?
Yes. Yes.
Similarly, the cos theta is going to be the adjacent side.
Adjacent by the hypotenuse.
The angle, that is very important, the angle
Hmm.
theta, because whatever the angle, with respect to that only we are checking what is the opposite side of the angle theta and the adjacent side of the angle theta, right?
Okay.
Hypotenuse is actually equal to, according to this it is going to be A by C, right?
Yes.
So if you go for the other two angles, like other angle, sine 90 minus theta is also one of the angles. 90 minus theta is one angle, right? So
Yes.
its own opposite side is A over C, and the cosine 90 minus theta will be the adjacent side of 90 minus theta
B
over
by
hypotenuse. Yeah, that will be B by C. By comparing this is also equivalent to cos theta.
cos
You get that?
theta and cos 90 minus theta is equal.
Yeah, sine theta. Okay, so that is also quite handy, like a sine of 90 minus theta will be equal to cos of the angle theta. The cos of 90 minus theta will be sine theta. Okay, all these things are fine. We have clear idea about that, and everything is quite useful. No problem, right?
No, no, no.
And apart from that, we learned another trigonometric ratio, tan theta, which is actually opposite side of
The
angle
angle theta,
angle theta divided by adjacent side
adjacent
of
side of
angle.
angle theta.
Yeah, so that's good. So that is actually going to be B by A, Also, the definition for tan theta is actually sin theta by cosine theta.
By cos. Yeah.
Okay, that is also, it will give you b by c divided by a by c, which is actually b by a.
Yes.
Okay, so all these things are fine. It's all good, and we know all this relationship. Let's go to the, with all this understanding, let's go to the given problem. So have you looked into the problem? Right? The
Yes.
problem looks
Yes.
like the angle, this is 130 degree, and this angle is
20.
20 degree, and this is 30 degree.
Yeah.
Because of that, because I'm trying to solve it, right? Because
Yeah.
this is 30,
That is
then
that.
only 20 plus 30 is 50, then 50 plus 130 will be 180.
Yes, I got that.
Yeah, okay. And we are given with this length is a 6, right?
Yes.
And this whole length is a A,
Mm.
and this length is a C, right?
Yeah.
Okay, fine. Because this one we found it like so. Normally, when the side is written as a lowercase a, this angle is normally written as a capital A. Okay, this angle under the corner vertex.
Okay.
So this is actually C, and this is our B. Okay, because the C is coming from this C. This is a lowercase c, and this is the opposite side will be the angle will be the, so this is actually our B, lowercase b.
Okay.
Okay. So now we found the C, we found it. So first question asked was what is the angle C?
Yeah.
So C angle was what? So to do that, we know that we actually know A angle is 130 and B angle is 30 degree. So A plus B plus C is actually
Be equal
180.
to 180 degrees.
Yeah, from this we know that the C is nothing but 180, take away A, take away B, that simplified to 20, or 30 degree, right?
30. Yes.
Okay, that's okay, because of the basic property from the right angle, any triangle, we know that the sum of the three angles in a triangle should be 180. We found that, but the other two things that we have to find what is A and
A
what
and
is C, right? Given that the B is actually 6,
6.
fine.
Yes.
But you see that the given triangle is not a right angle triangle, right?
Yeah. Yes.
So we know, another property about right angle triangle like Pythagoras, those things. So we need to try to see whether the knowledge we have about the right angle triangle can be used on this non right angle triangle. Okay,
Okay.
so one way to do that is, let's draw a altitude, the one from the angle top one going all the way down to meet the other side in a perpendicular angle.
Okay.
Okay, so call this as a, for example, call this point as a D. Then the triangle ACD is a right angle triangle, right?
Yes. Yes.
Right angle triangle. This is how we start using our knowledge to improvise what are all the new things or what we could do to solve a problem. Okay.
Okay.
So now in this ACD, angle D is 90 degree, right?
Yes.
I put it more specifically, ADC, angle ADC. So you start from the point A, go to D, and go to C. This is 90 degree, isn't it?
Yes.
So angle ACD, what is that?
Angle ACD is 30 degrees.
30 degree. What is angle uh, CAD?
60 degrees.
Okay, that comes from this triangle on its own. ACD triangle should, the sum of the three angles must be 180, because of that
180. Yes.
so this angle, you are saying this angle alone is a 60 degree, right?
Yes. Yes.
Good, well, good. But as we made it as a call it as a right angle triangle, we have some advantage. Okay, call this, we separated the BC segment or the side of the triangle into a BD plus BC. So call this particular length as a x. Okay, let
Okay. Yes.
BD is actually equal to x. Then tell me what is CD or DC.
Can be y.
Why? You know that BC is already A, right? We know BC is completely A. That is given in the problem, right?
Oh, so a minus x.
Yeah, the CD is nothing
Okay.
but BC minus. So be alert and be with the problem, okay? Because
Okay.
I started saying we can take one unknown as a x, then another thing, why it has to be another new unknown? Unless
Okay.
we need to give it as a value, we are okay with that, right?
Yes.
So BC take away our BD, isn't it?
Yeah.
So because of that, we know BC is a minus BD. We already given a variable value x, so A minus x, right?
Yes.
Okay. So now if you see, and also call this side the let AD be a y. I call this particular length as a y. Okay.
Oh. Yeah.
So now look at the in triangle, the right angle triangle ABD. We can use the Pythagoras, right?
Yes.
That can help with that. Also in
Can
triangle,
we just
yeah, in triangle, yeah, you can tell me whatever you feel like that will solve the problem much more
since
easy.
cos, we know that cos 30 is root 3 by
Okay,
2.
so you are going to the ACD triangle. You are saying cos.
Cos 30 is root 3 by 2.
Why root B?
Root 3 by 2.
Yeah, the angle we know,
Yeah,
but
yeah.
according to the triangle, cos 30 is adjacent side by hypotenuse, right?
Yes.
So cos 30 adjacent side is what?
Yeah, adjacent side will be CD, which is a minus x.
Okay, CD divided by AC,
AC,
isn't it?
yes.
So that will be A minus X divided by our B, which is our,
B, yeah. 6.
yeah, which is, okay, which is our 6. Let it be. So you are saying cos 30 will be, so will this help to solve the problem? Anything? Nothing
No,
solid.
because,
You are saying A minus X divided by our 6 will be root 3 by 2.
yeah,
The X is unknown, A is unknown. Do you get that?
yeah, yeah.
So that is why I kept it in the, look at the, okay, so look at the ABD.
ABD, yes, yes.
Okay, but okay, even in this triangle, the triangle ACD, you went for cos 30. I would have gone for sin 30. What sin 30 would have helped us? The
Oh, we could
adjacent
have
side.
got the value of y.
You see, we solve one problem.
Yeah,
So AD over AC, that is actually y over 6, right?
yes.
So y is actually equal to 3.
3, yeah.
Okay, so we have one unknown solved because of taking this. So that is the way we have to look for what kind of mathematical function or the operation that can help us to step further. Okay,
Okay,
nothing I'm doing in all the possible ways, but we need to be very shrewd and very much alert with what is going on and what we could do with that. Okay, so now we know
yes,
the y. So when we know the y, look at the in triangle uh, ABD. Okay, so we know the
yes,
y is actually nothing but our value 3. So we
yes,
know the, So this angle also we know, but look at the tan, the angle 20. So the x is an unknown, right?
Yes.
So if you want to solve for, because we know the y and we know one angle, so according to the angle 20 degree, the y is the opposite side and x is the adjacent side, isn't it?
Yes.
So if you take tan 20 degree, that will be AD divided
By B.
BD. Could you get this if I have not mentioned about this? That after getting the y value, we could go to the other right angle triangle and use the tan 20 degree.
Yes, I could have got it, but I don't know the value of tan 20. So.
Yeah, but let's say you are allowed to use the calculator, then in that case
Okay.
you're okay with that, right? Because I'm proceeding with the thought process. What we could do geometrically, drawing something like the altitude,
Okay.
and then using the two right angle triangle, using the Pythagoras or using the sine, cosine and the tan trigonometric ratios, can we solve for the newly introduced x and y? Because of that, the a and the c.
Okay.
So that is the thought process I'm looking at. So the AD is actually y over BD is a x. So we know that
Yes.
it is actually y is a 3 over x. So simply this tells us x is 3 over tan 20.
Yes.
Okay, let it be. I mean, we let's say if we have calculator, we can substitute the 20, and we don't need to mean, because 3 by tan 20 is a number. That is what we want, right?
Yes.
We got another thing as this is one thing, right?
Yes.
Now we got the x and y. So if you know x and y, what else can be from that? What else can be calculated?
Okay.
Look at the diagram. Help
C can
yourself.
be correct.
See, in triangle ABD, C is actually nothing but square root of x square plus y square, right?
Yes.
So we know that this is actually equal to square root of, so the 3 squared can be taken out as a 3 square root of 1 over tan 20 square, right?
Yes.
Plus 1.
Yeah.
So I took the 3 squared in both the things as outside. We get that?
Okay. Yeah. Yeah.
So once we know the tan 20 number, then we can square it, take the reciprocal, add 1, take the square root, multiply it by 3 will give you the c value.
Yes.
Okay. When we solved the x and we solved the c, and then what is left out?
A. We have to find A.
A. But what we can do for that?
1 second. So first, actually, I took cos 30 as root 3 by 2, and I found a minus x to be 3 root 3.
Okay, now we know the x value. So you are saying that, okay, so start from, you are saying that use this.
Yes.
So a minus x divided by 6 is actually equal to root 3 by 2. So
Yeah.
that is a minus x is actually equal to 3 root 3.
3 root 3. Yeah.
Right? So the x is known as a 3 by tan 20. So a is actually 3 root 3 plus x
plus x by tan
equal to 3 root 3 plus 3 by tan 20. Right?
Yes.
So this is a. So we solved for the a also. So a we got, c we got, b already given. So all the sides are found, right?
Yes.
Okay, I mean, there is nothing harm in doing all this stuff and everything, but what in solving this problem, what we did, straight away the right angle triangle was not given to us, but we used the property, first property of any triangle, the sum of the three angles should be 180. Because of that, the first unknown angle was found, and then as there is no 90 degree in the given triangle, we introduced a altitude side. Because of that, we split the given triangle into two right angle triangles, and because of that we could use the Pythagoras and also the trigonometric functions like sine, cosine and tan, and we solve the problem, right?
Yes.
So this is all about trigonometry. Any math is like that. Okay,
Okay.
so no problem, right?
No problem.
Okay, I will mean okay, the numbers and all these things are all okay. So it actually led us to go to the final answer. But I would say the thing is not about how to solve the problem. It's about what are all the things available from the given problem or the problem what we understood, and then what are all the things can be done with that and why we are doing that. That is more important. Do you get that?
Yes.
So every problem you solve or even the understanding we have, keep asking the question why, and the why should go to the level that we could connect with what we already know. So the new things what we are doing will get more strength and our confidence will develop on that. Okay, so I mean I have told that already to you. Let's go for a more generic way of doing something with a non-right angle triangle. Okay, call that as a ABC for example, right?
Yes.
Okay. So this side will be what? The angle A, this angle will be a A, right? So the opposite to the A, we call this as a lowercase a. Opposite to the capital B, we call this as a lowercase b. Opposite to capital C will be our the C. Okay. Are you okay?
Okay.
Okay. So tell me what we can do further. Now, first of all, I mean, I have not told what is the problem here, but I have drawn
Yeah.
a non-right angle triangle and given the vertices names as ABC, and they could be used as the angle value also. And opposite to the capital letter angles, the sides length are written as a lowercase ABC. Okay.
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 We can drop an altitude.
Okay, we can do that. Okay. Because of that, what is going to happen for the problem? So we are making this as a 90 degree, right?
90 degree. Yes.
Okay. Now,
Okay, so we can call the point, that point is, I guess, D.
capital D, and we could call this length as a X,
Yeah,
for
X,
example, right?
and
Okay.
this will be, the other BD will be C minus X.
P minus X, and this unknown for handy purpose
Y.
we can call that
Yeah.
as a Y. Good. Now, what we can do?
Yes, so
So we have two tools. Once we brought the right angle triangle, right angle into
you
the
can also use
triangle.
Pythagoras theorem instead of
Two things.
like
One is Pythagoras, and another thing is the
by
sine and
using the sine and
the
cos.
trigonometric functions can help. That is all about trigonometry mathematics. Okay. So now
Okay.
try to do that. So first, okay, Pythagoras is telling what? Tell the both, because there are two right angle triangle, tell both the Pythagoras in the squared
Okay,
value.
so it will be one second. C minus X the whole square.
Okay, you start with the hypotenuse. Hypotenuse square. Tell me the hypotenuse square. What hypotenuse you want to write first?
Okay, A square.
Okay, so in triangle
CDD.
BCD, we have a squared is actually equal to
C minus X the whole square plus Y square.
Okay, good. Okay, also if we want, we can even expand this, but time being, leave it like that. In triangle, the other right angle triangle is ACD. The
Yes.
Pythagoras is telling us
B square is equal to X square plus Y square.
X square plus Y square. So now, call this as equation number 1. This is equation number 2. Now, if you see in the equation number 1, right hand side, C minus X whole square, when we expand, we will get a plus X square. Do you see that?
Yeah, we'll
But
get a
on
plus.
one,
Yes.
yeah, the one is actually going to help us. A squared is actually equal to c squared plus
C
x
square
squared.
plus x square plus 2cx. Sorry, minus 2cx.
Careful, minus cx to cx plus y squared.
Plus y.
Okay, if you rearrange this can be written as a x squared plus y squared plus c squared minus 2cx. So this will be, this whole thing can be
B square.
using, yeah, b square plus c square minus
Minus
2cx.
2cx.
So now if you see only with the Pythagoras, for a non-right angle triangle, this is a new Pythagoras. Do you get that?
Yes.
Because normally the Pythagoras is meant for right angle triangle, that will look like hypotenuse square is actually equal to the sum of the squares of the other two sides. But right angle triangle, we are saying something similar. A squared is equal to b square plus c square, but we remove a minus 2cx. Do you see that extra bit?
Yes.
Actually this minus 2cx is actually the extra part, the area of the rectangle or something like that. I'm not going that detail fast, but still if you see the one what we derived, this equation is actually having an x, which is a new side we introduced. Do you get that?
Yes.
Because a b c, they are all sides of the original ABC triangle. So we are looking for, we know in a right angle triangle what are all the three sides, how they are related, and when we have the sine and cosine, how they are related, everything is defined for a right angle triangle. Okay.
Okay.
So we are trying to extend that knowledge and understanding from a right angle triangle to non-right angle triangle. In doing so, only using the Pythagoras, we went up to a point, a revised form of Pythagoras for non-right angle triangle. One side square is actually equal to b square plus c square minus 2cx, right?
Yes.
But in a non-right angle triangle, we cannot say that a is hypotenuse or b is hypotenuse or c is an hypotenuse. Okay. So
Yes.
for example, if I draw the altitude like this, right? Let's say this is a 90 degree. We can do that, right?
Yeah. Yes.
So then in that case, then call this as a d prime, for example. Then this length is a x prime and this is a y prime. Do you see what I'm doing?
Yes.
I'm doing
Yeah.
same similar thing what we did earlier. Then this piece will become a minus x prime. You get that?
Yes.
So in this case, we could have derived the same Pythagoras using the new altitude and everything. We could have come up with a different thing. It would have looked quickly if you see that using the, I mean, still what is this? B square is still x prime square plus y prime square, right?
Yes.
Okay, and the other one is, other right angle triangle would be, the hypotenuse is our c square, right?
Yes. So
Yeah, c square should be equal to,
yeah, c square should be equal to a. Sorry, one second.
a minus x whole
A
square
minus x the whole square
plus y
plus
square.
y prime.
Oh, sorry, yeah, both should be prime. Okay.
Mm.
Okay, so if you expand this, that will be a squared plus x prime squared minus
Minus
2ax
2a
plus
prime.
y prime square.
Y prime.
So a squared combined the x prime squared and y prime squared, we can write it as a b squared minus 2a x prime. Do you see the beauty? Right? This
Yes.
is
Yes.
okay, we can call this as our, if you like, we can call this as a 4, and using 4 and 5, we got a 6.
6.
And similarly, we could have drawn another altitude all the way from B, go all the way to the side AC. We could have made a different right angle triangles, right? You see what I'm
Yes, sir.
saying?
Yes, yes.
We could have drawn one like this.
Mm.
And if this is a right angle triangle, I mean there are two of them, and can you okay, now you should get a generic idea how that final equation would be. So definitely call that as a double prime. That would have, so I'm saying that this you can call that as a x double prime, and this as a y double prime. So this side, the remaining side will be b minus. Are you following me?
Yes, sir.
Okay, so that would have easily given us, so this particular triangle, so y prime and the y double prime, x double prime would have given a squared is actually equal to x double prime square plus y double prime square. Are you with me?
Yes, sir.
And b squared would have been our c minus, no, sorry, we have, yeah, we have drawn this one, right? Then in this x square plus, this is not right. That is the right angle triangle. C square, okay, okay, this is not right. So you look at that. Can you look at the triangle, the new right angle triangle I have drawn?
Yes, sir.
Okay, let me draw only that right angle, those two right angle triangles. So it will look like this, and this is our altitude. So because of this, what we are trying to say, if this is the 90-degree, then if you call this side as a x double prime, then this piece will be b minus x double prime. Okay.
Yes, sir.
Okay. And this side is still a, and this side we call it as a y double prime, and this side is still our c, isn't it?
Yes, sir.
So a will be, so a squared will be equal to, yeah, I was right, isn't it? X double prime square plus y double prime square, right? And the c
Yes, sir.
square would be b minus x double prime whole square plus
Y double prime.
square, right? So this would have given us c squared is nothing but a squared plus b square minus 2 b x double prime. Are you with me?
Yes, sir.
Do you get that? So if we had only one right angle triangle, we would have had only one Pythagoras. That is, hypotenuse square is actually equal to sum of the squares of the other two small sides, right? But when we have a non-right angle triangle, we could split them into three different possible ways of pair of two right angle triangles, right?
Yes, sir.
Yeah, I mean, are you following me, or you find it getting complicated?
This last one alone. I understood till c square is equal to a square plus b square minus 2bx.
Which one? The equation 1, 2, 3, 4, 5, 6 is okay, right?
Yeah, yeah, yeah. The last one alone I found it a little bit hard, but now I've got it.
Yeah, but all we are doing is in cyclic, I mean, the given non-right angle triangle can be split into pair
3
of
altitudes. Each side.
the three different altitudes will give
Yeah,
us 3 different possible Pythagoras.
Yes.
That is what we have done. Do you get that?
Yes, uncle.
So now, in doing so, we have done some job, but you see the x prime and the x double prime, they are not in the given side of the right triangle. Do you get that? That is not look that good. So to deal with that, what we could have done, look at that. Now that is what the trigonometric functions are going to help us. Okay. Now look at the x. Look at the x. What is x? X is actually our AD, right?
Yeah, x is AD, correct. Yes.
AD. So look at the x length and look at that particular triangle involving the right angle triangle involving the x. So I would write it as in ACD, right? In triangle ACD.
Yeah.
Look at the x and can we use the one of the trigonometric functions so that the x length can be related to the known quantities like the angle ABC or the sides ABC?
Yes, it's possible.
Yeah, which one? Tell me which trigonometric function on what angle can help that?
For example, we can take tan.
Look at the, I mean, I already written the triangle, the right angle triangle ACD. In ACD, what we AD is a x and the AC is already only B, right?
Okay, yeah. So to find B, we can.
You know what you did when we solved the problem? We used the tan. So you are going for tan without thinking or without looking into, or you are not giving the respect for what is available to us. Do you get that?
Yes.
So in the ACD, I mean, if you cannot carefully look into the diagram, what is already available, you can draw separately. As you are quite young and not done lot of problem like that, you can separately draw that to get a better idea, right? So this we call that as a x, this is a y, and this is a
B.
Now tell me, because in the first one we have derived x is the culprit, right?
Yeah.
Where I am underlining in this particular revised Pythagoras, x is the culprit. Apart from that, the ABC, they are all known to us, right?
Yeah.
Because
ABC is known to us. Okay.
So that is why I'm going to the point, like, can you look carefully into the triangle, right angle triangle ACD that I have drawn separately. Look carefully and tell me how the x can be expressed in terms of known quantities.
Okay.
The given hint is you can use the trigonometric function. Now tell me what trigonometric function acting on what angle will relate the x with the other known quantities.
Okay. So the cosine of angle CAD.
That is A itself, right?
Okay.
A.
Yeah.
Cosine A is
will be
equal
to x by b.
X over b. Because of that, x is actually b cos capital A. Right? This is beautiful, right? So because of that, so we can write 3. The equation 3 becomes a squared equals b squared plus c squared minus 2 bc cos A. You get that?
Yes.
It's not very complicated. Just what we did, we know Pythagoras for a right angle triangle, and we know the sine and cosine trigonometric functions for right angle triangle definitions, and we just went for a non-right angle triangle and used the altitude to split the non-right angle triangle into pair of 2 right angle triangles, and in doing so we just applied the Pythagoras and we got one modified or revised Pythagoras for non-right angle triangle, and in there we find one newly introduced side, and using the trigonometric function cosine, even we could even substitute, remove that with the known values, and we got a beautiful new Pythagoras which will look like a square equal to b square plus c square minus 2bc cos a. You get that?
Yes.
We call that as a cosine rule. This formula is called a cosine rule.
Okay.
But I would say that it is nothing but a Pythagoras for the non-right angle triangle. Okay. So how to remember this cosine rule is very easy. If you take any side square is actually equal to sum of the other two sides minus twice the product of the other two sides multiplied by cosine of the angle for which side we are looking for. You get that?
Yes, sir.
Okay. Are you okay? Any questions or doubts so far?
No.
So if we draw, like let me draw some triangle, it doesn't matter, I call that as a XYZ. Then the opposite side length will be lowercase x, lowercase z. Lowercase y, right?
Yes.
So we call this angle as a capital X and this angle as a capital Z, capital Y. So we are saying if you take any particular side squared, all we need to do is the other two side y squared plus z squared minus 2yz, right, cos of capital X. Because this side, these two are connected.
Okay.
The x squared. So we can also write the other two cosine rule. That will be y squared will be. Can you tell me what is other two?
Okay. So y square will be equal to x square plus z square minus 2 xz.
The product of the two squared,
Yes.
right? That's it. Okay. And the cosine of
y. Capital Y.
Okay. So the last one would be our z square is
Z
actually
square.
equal
Is equal to x square plus y square.
to 2xy cosine z.
Yes.
Simple, right?
Yes.
Okay. So they call this as a cosine rule. So what has happened, if you see the problem, the given problem for our original problem, we had this angle was a 20 degree given, this angle was a 130, right?
Yes.
Isn't it?
And that would be, we found it out to be 30.
Yeah, 30 degree we have found it, but now you see this was given, right?
Yes.
Okay, let it be. Okay, I will come back to this, but the cosine, these three things are called cosine rule. You're okay with that, right? Cosine rules. All the three you are okay, right?
Yes.
Okay, so you can apply that, but time being I go for a different situation. Let's take this and then try to draw a altitude. Call that as a B, C, for example. Originally this is a and the whole length is a lowercase c and whole length is a lowercase b, right?
Yes.
If we draw this right angle triangle, then we have this as our x, this as our y, for example. This will be c minus x, right?
Yes.
Now call this point as a D. Now in triangle ACD, what will be our sine A?
In triangle ACD, sine of angle A will be y by b.
Y by b, right? Because of
Yes.
that, we can write y is actually, the unknown is actually equal to b times sine
B
A.
sine A.
Okay. Now go to the other triangle. In triangle, other right angle triangle A, no, not A, B, C, D, right?
Yes.
So this angle is our, so now go for the sine B.
Okay. So sine of B will be equal to y by a.
Y by A. Because of that, we can write the unknown y is actually A sine B.
Yes.
So compare the equation 1 and 2. That tells us, compare 1 and 2. So that tells us both are y. So that should be B sine A should be equal to A.
A sine B.
So this actually, it is written in a particular form so that A over sine A, divide both sides by sine A sine B, that will be equal to B over sine B.
Okay.
Okay, this is called a sine rule.
Okay.
So that is very easy. You take in a non-right angle triangle, even a right angle triangle also this will holds good. In a non-right angle triangle, it will look like a side length divided by the sine of the angle, that same angle. Do you get that?
Yes, sir.
Equal to the other side divided by sine of that angle. So in doing so, we can write in cyclic. So any right angle triangle, non-right angle triangle, let's say
Yes.
ABC, and we call this as a C, A and B. Then we say A over sine A is actually equal to B over sine B. We could prove the other one also, C over sine C.
Yes.
This is called the sine rule. Okay.
Okay.
Are you okay?
Yes, sir.
So we have derived all the three cosine rules and the sine rule also, and we know how it works. Simply they are extension of, so if you convert this into a right angle triangle, for example, okay, special case, okay, so the
Okay.
A become a 90 degrees, so this will be still C A, sorry, B A and CB. So if you start using this for our, so the angle, simply in this case, a special case, angle A is 90 degree, right?
Yes.
So because of that, A over sine 90 degree should be equal to B over sine B. Okay, what is sine 90?
Sine 90 is 1.
Okay, that will be A equal to B by sine B. This actually tells sine B is nothing but B over A. This is our original definition. Do you get that?
Yes.
So the sine rule is actually nothing but the, we can use any two of them, like A by sine A equal to B by sine B, or B by sine B equal to C by sine C, or A by sine A equal to C by sine C. These are all the new trigonometric function definition for our non-right angle triangle. Do you get that?
Yes, sir.
So simply we could say that in this one, sine B divided by sine A is actually equal to the B over A. You get that?
Yeah.
So we have extended the Pythagoras theorem for non-right angle triangle. Also we have extended the definition for the sine angle also, definition like this, combination of these two. Okay.
Okay.
So how this can be applicable, like as I said, take that problem, sine rule could have easily solved the problem straight away. This was given as a 6, this is 20 and this is 130. Then we calculated this as our 30 degree, right?
Yes.
Okay, so now this one is, they called this as a and C. So now by the look of it, okay, we have solved this problem even before we understood and derived the cosine rule and the sine rule. But after knowing the sine rule and the cosine rule for this problem, how to solve the A and C? What you do?
Yeah. So we can take
Which rule you will go for?
This one, the sine rule.
Yeah, reason being, what is the rationale
Because
for that? You see, the cosine rule is actually deal with three sides. Something like a square is actually equal to b square plus c square minus 2bc cosine of that angle. But
yeah,
sine rule will deal with
deal
any
with
two
all
sides
the
and
three.
two angles. So whenever you find a problem, a situation where you are dealing with one angle and three sides, then cosine rule will be handy.
Okay.
But when you come to some problem where you know the two angles and the one side, then the third side, other side can be calculated from the. So that is a situation here. You are unknown with the two sides, the A and the C. So deal with, call this as a, so we can easily write A over sine 130 degree is actually equal to 6 over sine 20 degree.
Yes.
You get that? So this one will tell us A is nothing but 6 sine 130 degree divided by sine 20. All are known quantity. On the other side, using the calculator, we can calculate it, right?
Yes.
Similarly, this for calculating the C divided by sine 30 would be equal to our the other 6 over sine 20.
Yes.
So this will tell the C is actually nothing but 6 times sine 30 by the sine 20. Okay.
Yeah.
So also, I will end with the cosine rule. The cosine rule is written as a square is actually equal to b square plus c square minus 2bc cos a, right?
Okay.
So this can be also written as, the 2bc cos a is actually equal to b squared plus c squared minus a squared, right? So cos angle A is actually b squared plus c squared minus a square over 2bc. So for a non-right angle triangle, the cos of an angle can be calculated by the ratio of, in the numerator, we need to take the other two sides, whatever the angle. So the triangle always written as, like this is angle A, B, C for example, then we call this as a B, this is lowercase c and A. So if you are looking for the cos of this angle A, then take the other two sides, the square of b square plus c square, take away the a square divided by twice the bc. Okay. So similarly, we can write the cos b and also cos c. Are you okay? So whenever we have a non-right angle triangle and something like, if you know two sides and one angle, how to deal with the other angles or something like that, then we could use the sine rule, cosine rule, depending on what is known to us and how the sine rule and the cosine rule are dealing with. So when you know two angles and one side, then cosine rule, sine rule will come into picture. Whenever you know three sides and if you want to calculate the other angles, then easily the cosine rule comes into picture. Okay.
Okay.
Are you okay?
Yes, sir.
So you feel comfortable with the cosine rule,
Yes.
sine rule, and
Yes.
they are applicable. Okay. So think about how these things can also help us to find the what is the area of a triangle.
Okay.
If you are given a triangle,
Half into base into height.
okay, the area is half into base into height. Okay, then
And there is also the
ABC, can we do that? Because the base is B. Let's say the
Heron's
base
formula.
is B. You see, there will be the H you are asking for, but we don't have the H, right?
Yes.
Then in that case, let's say if the angle C is given, for example, then call this as a D, then the sine C, the sine angle C is actually the opposite side by hypotenuse A. isn't it?
Yes. Yes.
So this tells us altitude is nothing but A sin C. So because
Yeah.
of that, we can have a new formula for the area of base into, so that is base into A sin C, right? Rearrange that and write it as area. The area is nothing but of AB sin C. So if you know the side lengths, then of product of the two sides multiplied by sine of the other angle. Do you get that? If you take the product of AB, then the angle between those two sides, sine of that will come to the existence. Okay. Can you tell me the other two formulas? It would be A, B, C, then sine of?
Sin A.
Good. And how about another formula of?
Half AC into sin B.
So you see all these applications and everything will pop up whenever we need at the right place, we can use them. So that is how we extend our knowledge for applying for other things depending on the situation and the given problem or the requirement. Okay.
Okay.
Okay, you feel more confident with the trigonometry?
Yes, sir.
Okay, we work on more problem. We can proceed with what will happen when you have sum of two angles or difference of two angles. All those things we will see next week. Okay.
Okay. Okay.
Okay then. Next week is I cannot available for Sunday. Either we have to have it some other day or we have to skip it next week and the following week we can.
Okay.
We will fix it depending on that. Okay.
Yes. Yes, uncle.
Okay. Okay. Take care. Bye.
Thank you, uncle. Bye.
Yeah. Bye.